And all right, MOFA, as we're commonly known, as as a practice, we have been around since 2002. Although MOFA was formally formulated in 2007, and in all these years of practice, we have handled various verticals. We've handled more than 170 plus projects. We've been around in 7 verticals, designed more than 5 million square feet of area. And in these last 2 decades of practice, there is a lot of tremendous learning that has happened. And each of our work is a new work to learn for the future, for our practice. It's always a work in progress. That's the philosophy we've always formulated. That no project is complete. It's always a start or a learning into a new project. 2 of our major verticals that I'm going to be covering today, one being private homes and the other being public spaces. This is a collection of few of the residences that we have done in all these years. And this slide is important to me because it shows a progression. It shows an yearly progression from 2003 to 2020 now. And what you would see is how we have gone from larger homes to smaller homes. And there is a reason to do something like that. And we call it SMLXL and XXL. There is a great need for houses in this country, and it has been documented over and over again. There are various segments which we design for, and I'm not talking about mass housing here, I'm talking about private homes. And especially with today's scenario, with what we are facing, homes have become an extremely crucial part. And with the plot size going smaller, urban density is increasing. And now with the added thing of working from home, the homes of the future will have to have a lot more going on than just being these large, fancy farmhouses that we dealt with in the beginning of our practice. What you see on top, 2003, is a farmhouse on a 2-acre land with only 3 residents, 3 people who would have stayed there, and a built-up area of about 20 to 25,000 square foot. What we have come down to now in 2018, 2019 are mini homes with residents or multi-family residences with people about 7 to 8 to even going up to 15 or 16 people, interconnected floor-wise, not divided, on smaller plot areas of as small as 160 square meter plot, which is literally 1/20th or 1/25th of the farmhouse plot that we had designed way back in 2003. The farmhouse that we did, some more large homes, farmhouses, going on to the starting of urban homes with 500 to 800 to 1,000 square meter plot areas in Delhi. A 500 square meter plot area, multi-family residence, about 15 residents and multiple bedrooms interconnected from within. I'm not sharing details of these houses today, except for one that I'm going to be talking about. Another 500 square meter plot area, multi-family residence interconnected from inside with an urban garden or an urban forest on the terrace. A smaller residence, again for a multi-family. The interiors have been connected through the central courtyard, a skylight, an internal space that connects all the bedrooms together. To a house we're doing in Bangalore right now, which is less than 200 square meter of plot area. And number of members in the family are again between 10 to 12. A hostel that we're designing, which is meant for students, or students' housing rather. I wanted to put this project in particular, which is a low-cost project. We're using containers to build it. About 60 students would be staying here with a plot area of not more than 60 square meter. To a house that we're dealing right now in the middle of an urban setting, a highway or a flyover on one side, loud noises, urban traffic, a plot area of 160 square meter, multi-family, multifunctional. The basement is supposed to be a dance studio run by one of the family members. The upper house being a private home, and also on the ground floor an office for another member of the family who will be running his entire office and operations from home itself post-COVID. So as you can see, in a tight scenario, a lot of functions with the family members coming together. This is a house that we realized would be used, would be constructed, needs to be constructed in a budget which is a controlled budget. We are using prefabrication within this. The entire house is done using steel construction and assembled like a kit of parts on site and put together in the fastest possible manner for saving resources, reducing the carbon footprint, and making it into this complex piece of machinery that works efficiently well together. A short video for you to understand what this whole house is all about. That's the urban setting where the house sits. Taken a winding staircase around the house on the periphery so that the internals can be made free, interconnected. dance school in the basement. All right, from there on, scale versus challenges. What we have realized over a period of time that being a larger plot size, no restrictions, a lot of money, mostly the clients are looking for an iconic, high-end kind of a house. Yes, it's great to come up with these playful, iconic kind of structures, but does not leave us with any kind of challenges to come up with those with a new language or something which we are dealing with. And as the plot size gets smaller and the budget gets lower, challenges as a designer increases for us drastically. And this is where we start enjoying the project. And this is where the innovation starts happening. So keeping this house in mind, which is being done at a budget of mere 2.5 crore, which is fairly economical from Delhi standards. The house is being planned to be completed in 12 months. Except for this break of 3 months that happened in between, we were pretty much on target with it. And we were pretty much on target either with time and also with the cost of the entire thing. So moving on from the houses to some of our other projects, and what we have over the years learned and understood, the first 10 years when we were understanding what we were wanting to do, what we were wanting to achieve with architecture, we went through various kinds of concepts which are form related, which were context related, which were programmatic, which were of various kinds dealing with these various arrays of projects. In the next 10 years, we started integrating services to a next level where we started innovating with water management systems to integration of systems to where various MEP systems could talk to each other, could become self-generative, could also become not just energy positive spaces, but also water conservation, and to a level where the units start producing their own energy and water requirements. So they start serving themselves, going off the grid. What we're looking at in the next coming decade is the use of IoT, bioadaptability, a lot of simulation that we have been doing to test, to try out our models, to try out various aspects within our project. Ease of construction from fabrication in the industry, in the factory, onto the site straight away. So how we can increase or smoothen out our workflow right from our desk, from what we design to how it goes into the manufacturing unit, gets constructed, gets built, fabricated, and gets assembled on site. So the entire process of how to smoothen that without much errors, keeping the budgets in control and keeping time in control is what we are striving towards at this point in time. And this, of course, involves a lot of real-time data analysis, whether it is the weather and simulation, whether it is the timeline economic simulations, or whether it is the capability of the factories and the industry that are manufacturing our buildings. Quick preview, old houses. I'm going to run through this. Some of the old projects, a resort we designed for Club Mahindra. It was a competition we had done with a firm in Mumbai called Parallax. A club we designed for Omax as a continuous space, a shooting academy which is built in Madhya Pradesh, Bhopal, as a national shooting academy. A small pavilion, a competition we entered for the redesigning of dance school at Moulin Rouge, where the windmill itself was used as the central driving force to create these spaces with churn around and these studios that sit around a void that is left behind after the windmill is removed. An office coming down to a resort which started in 2010, and a project which we perceived as these biomorphic pods which would sit or grow out of the site just like an anthill, or rather sit where these units could help grow moss, grass all over them and disappear within the existing landscape. On a site in Nagar, which is close to Manali in Himachal Pradesh. That's the site, that's the view from the site rather. what we look at. This was the first sketch that we made, an anthill inspired architecture. These pods which would grow out of the hill, 6 pods, which have now become almost 6 pods plus another 3 units which are accommodated under these. So 9 total units in this small resort. And with the growth of moss over it, there is a lot of moss that grows automatically on rocks and on concrete surfaces. And we've researched a lot on the local species that grow without any maintenance on top of the concrete roof. We intend these blocks or these pods to kind of merge with the entire landscape with just these skylights like eyes into the sky looking and getting light through them. Being a hilly site, the construction is extremely challenging. We are not able to construct more than 7 months in a year because of snow, rains, and other factors. So the construction has been painfully slow, and it has helped us understand a lot about construction industry as such when we have to conceive designs like these. With RCC walls, which are on the lower level to hold these pods together. Most of the units on top, the steel structure came as a prefab frames from the factory in Delhi, assembled with connecting arms in between, again done as prefab, covered with a ferrocement shell because that was the most feasible and economical solution given the site out there and given the conditions and the budgets for the project. Of course, a thin shell of 40 mm with insulation has taken care of all our needs of waterproofing and even the snow loads outside. The unit that sits looking onto the valley. At this stage, the glasses have also been put in. The interiors are going on. Painfully slow process. We still haven't been able to complete this project. The biggest challenge that we faced, one of them was with these triangulated skylights and openings, which are all over in these pods, to make them dark if needed, because these are resorts. And if people do need to have a complete shutout from the light in the afternoon, how would one draw curtains on them? So for that, we resolved to a childhood technique of making these origamic fans, and how these fans could be automated, or rather these curtains that open out like origamic fans, which are light responsive or could be manually controlled. We built a small prototype using a paper fan in the office, did the programming, put the sensors ourselves, and ran a small experiment and multiple experiments with series of changing light conditions, colors, spectrums to see how these fans open out and how fast they respond. So based on this, we have now proposed to make these curtains on our own. We've tied up with an agency for which we are doing the programming. We're helping with the hardware development, and these curtains are going to be put in place for these units. A look from the valley below. Coming on to National Institute of Fashion Technology in Kangra 2010, we won it as a competition, an institution and a student housing on a hilly site of 16 acres. Kangra, if you know, in McLeodganj is at a moderate height, and the site offered us a difference of about 40 meters from the lowest to the highest point, with almost 60 to 70 banyan and mango trees. This is the site particularly for the hostels or for the student housing, where we decided not to cut even a single tree or not to even touch a single branch of a tree, but to map the site in detail, including its contours, its trees, its branches, its foliage, to such an extent that we could do an integrated design within this whole scenario. So right from contour mapping, dividing of these spaces or the rooms that we called it in modules of 10 feet by 10 feet, rather 3 meter by 3 meter, we divided the entire site using a grid of these functional cubes in a way that another thing we didn't want to do was grade the land. We didn't want to cut the land and make these platforms usually how they're done in the hills, doing any modern construction, because not only do you lose the ground cover, but you also lose in a lot of areas the natural water flow that was always there on that site. So we wanted to go with the natural flow without disturbing the land and place the units exactly how organically they could come up, like any other village in Himachal or Kangra that is there, because each of those units, they come up wherever they are without disturbing the sensitive balance of the land. Introduce the light cubes where the voids, lights for ventilation that would come in, the circulation routes, plinth formations, the lower level, upper level, vertical connectors, and the entire plan sort of emerged in a manner, in a very organic manner, where these cross fingers of corridors which ran at various levels, each of the units also sit at their respective level of the contour itself. Some photographs during the construction where the existing trees are respected have been held together using retaining walls, a larger sort of area around them. Each tree was given close to 3 to 4 meters of area, and so that the roots could have enough space to sort of grow and not jostle with the concrete or the retaining walls of these structures. So the existing trees and the architecture which is integrated within that network of trees. Steps, corridors, each unit at a different level, a simple language that helped us achieve a lot of outdoor spaces for the students to sit around, to think, to mull over, and a perfect ideal setting for a design institution. In 2010, we won another competition to design an office for Delhi Pollution Control Committee. Here we wanted to create an example of an office where it would go completely off the grid. And being an office for Delhi pollution control, we wanted to create an office that does not create any pollution. And not just that, it also absorbs the pollution of the surrounding area or the micro area around it, the context like a sponge. The site tour given to us was in Rohini, next to a sewage drain, a large nala, which we used to our advantage. We proposed to the government to tap the water from the sewage water from that nala, generate gas for energy, liquid to use for our radiant cooling systems in the air conditioning, and the remaining segregated solid matter as a manure for the vegetation all over the project. We drew out a very detailed integrated systems plan, a flowchart of some sort where one system would help the other system in terms of talking to each other. And using IoT, each of these systems would create that balance or restore the balance where the entire office does not have to look for any energy requirements from the outside. It could go completely off the grid. It would generate its own potable water from the rain, and it would manage its own garbage in terms of generating energy. Plus, it would use the sewage water from the outside to use the energy. At the same time, we also worked with some scientists from Ahmedabad itself, rather, to come up with bentonite walls, or the clay walls, that could absorb a lot of carbon particulate matter from the parking lots and give out clean air into the environment. So as a concept, it was well worked out in its how it was going about to be. We had Terry involved with us doing the systems management and coming out with an entire report. Unfortunately, the project got stuck with DDA in Delhi because of bylaws. We were not allowed to build that roof on top. We were not allowed to do a lot of these setbacks and things. So a project of this kind, which could have become an office for the future, was just closed in our books and for our future studies. Another project in 2011, National Institute of Water Sports in Goa, won as a competition, set us onto a new challenge in construction, a new challenge in technology, and how to manage projects of this scale, not only by integrating prefabricated systems, but how to use the parametric architecture and the simulations to test each and every aspect that goes in building a project of this complexity and of this nature. As a concept, we saw this building as a link between the sea and the wave. Now, National Institute of Water Sports, if you guys know about it, it's a Ministry of Tourism venture in India. It's one of the only kind of project in Asia that gives licenses to adventure water sports players. It does training courses for the Navy in scuba diving and rescue operations, also does training courses for lifeguards all over India, and for all adventure sports related activities. So it's one institute that takes care of everything that's related to adventure sports in water, rescue operations, and even the Navy operations. So we saw this building as a very dynamic link between this energetic water that you're always dealing with, or the person who was always entering the sea, and we wanted to kind of translate that same energy field in the language or in the storytelling of the architecture. As a link between the sea and the surfer, as a tussle between the two, as a tension between the two, we wanted to have this sort of tension in the form and its spaces replicate it and to stay as and when a person walks through it, to feel that kind of tensile forces through it. We started with the study of paper models to visualize how the waves, how the interlocking of the form, how these things could work. And through series of paper models, through series of experiments, I think we must have done close to 70 to 80 iterations of this, clicked a lot of photographs, and we finally came up with the first model, which looked like this, which literally is a link between the land and the sea with these jetties going out into the water. This was a competition entry from which we won the competition. And when we started building the project, it had its own set of challenges with this roof which is more than 4,000 square meters of area, completely parametric, no module equal to each other, and a mammoth construction that lies in front of us. Because if you know, government constructions could be tedious. It's done by contractors who are not, it's a low cost, it's L1 bid. And to build a building of this sort has a challenges equivalent to be, let's say, if you're building a rocket and you're giving it to an L1 contractor, which usually does happen with building rockets in NASA also. But you have to be very, very clear about your documentation, about your drawing, or what you're proposing and how you're doing. So a tedious tendering process, a detailed tender was done by us. We knew about the entire construction at the time of tendering process, which means the working drawings were completed beforehand. More than 200 iterations of the roof were done, simulated, generated, with daylight simulations, skylights, how they would be, depending on what space requires how much of lighting. That was the first analysis. And an organic model was developed. We had to control costs. We had to get accuracy of this parametric design. And the accuracy we set was a tolerance of plus minus 10 mm, not more than that, for a project of this scale. Being restrictive in its budgets, we could not use cranes or other mechanical means to assemble a roof of this kind, which means we had to subdivide this large roof into smaller modules, like a small puzzle, which could be assembled back onto site again. So a streamlined roof was designed, which could also dissipate the wind pressure which was coming from the sea and make it more structurally safe and viable. To build each module, all the working drawings, all the fabrication drawings were generated within our office. X, Y's, and Z's for every part of the joint junction detail was given. And that was assembled. The Z's were achieved by all the waste reinforcement that was lying on site. So we built a platform of 5 meter by 5 meter in steel, a flat platform, and all the Z axis was achieved by using waste reinforcement cut into actual sizes, stack welded, so that each and every module could be individually made, generated like this, lifted by hand, joined together, welded into a large composite roof. We also did a detailed water analysis, a real-time rain analysis of Goa, because rains in Goa could be monstrous. If you've not designed for it, it could be a disaster. Looking at the water flow analysis, we were able to design the gutters. We were able to design the water flow on the entire site, thereby creating a large water collection pond, also for as a potable water for the institute, and create these on the periphery, this entire barrage of mounds, which could break down the high tide waves which are coming from the sea, that they don't flood the entire site during high tides and high wind and high storm situations. A double roof with the help of my friend Samir Kumar, who's also from CEPT and my batchmate. We came up with this entire double roof pressure equalized system, which I can explain in detail much later during the questions. More than 5,000 drawings were generated for the roof, and for the roof panels, we were using a simple color-coated sheet, which is the cheapest available material in the market, to make these panels, which are like origamic folded panels, assembled on site, which are right now going on. All the panels are there. They have been factory cut, CNC bent, brought to the site, and they are being put as a final roof. Being a large open roof, we needed to do an acoustic simulation so that the sound from one classroom does not spill over to the other classroom. We designed these clouds, these floating acoustic clouds, which suspend from the ceiling, and did a lot of simulations so as to, by placing speakers, volumes, various kinds of people, receiving and delivering points and checking what is the best insulation material or what is the best insulation design to prevent the sound spillage from one classroom to another. So a project which is almost towards its completion. In next 6 months, we'll have this building ready. Some of the photographs during construction, which were taken last year, from the model to the actual construction. We managed a tolerance of not more than plus minus 10 mm. The entire roof is precisely fabricated as what we had planned. It's a relationship to the sea. Coming to an installation we did about 3 years ago now, Urbanscape in Delhi itself during India Design. And if you guys are aware of what is India Design, it's a design expo that happens every year. And in 2017, we put a series of these installations in the entire central plaza of the expo. This project was done as an experiment from our end, where we wanted to study a system which could be done on site without the use of doing detailed drawings or the use of any kind of highly technical drawings, by using the skilled craftsmen and using as much waste steel or a scrap steel possible. What we did was we created, this was done as a dedication to all the trees that are being rampantly cut in Delhi due to rapid urbanization. We studied about 8 different trees of Delhi, which are commonly, which are there in the landscape of Delhi. And we represented the cut forms of those trees. Usually what happens is they cut the trees and they leave the stubs on. And those stubs remain in the city as this reminder, this ugly reminder that the tree has been removed. So we kind of use that expression of these stubs to be created through the scrap steel as this giant reminder in 1:1 scale to people of what is happening all across due to rapid urbanization. A lot of models done in clay to understand the form. We worked with Sushant from RatLab. He was also somebody who had interned with us, who had worked with us before he went to AAM in Zaha. So I collaborated with him, and we worked on the site itself for about 8 days. No drawings were created for this project. We worked only through models, through coding. Internal structure was done using MDF, and then the outer structure was assembled on site by various craftsmen by using their own individual techniques. So the group of craftsmen, each one came up with their own technique of welding these 1-inch metal strips. So we collected a lot of scrap metal from the market, got them cut in 1 mm strips, and the entire structure was covered using these strips by these craftsmen individually. Individual patterns of weaving, of covering emerged over a period of time, over these 9 days. And what we were able to understand and study how the human mind works, or how a mind of a craftsman works. Usually we work with a lot of algorithms written. The problem with an algorithm is it's written by one person. It doesn't have the complexity of the human brain. Here we wanted to integrate an algorithm written on the computer along with 40 different brains who would integrate it together seamlessly and come up with something new which is unpredictable. So a right mix of intuition with logic resulted us with these forms, these skins, these structures, which shimmered in light, looked different. Small movie just to show how the assembly happened, what these structures are about. Going on to a project which we are doing right now is Goa Heart, or Goa Bazaar is what we call it, a similar model to Delhi Heart, where a growth to the craftsman, a platform for the local craftsmen in Goa would be given as a craft bazaar, or Shilpgram as it's called in a lot of places. But here we wanted to bring a difference then compared to what, and all this, it's very sad to hear about what the person who introduced Delhi Heart to this country passed away last week. And I dedicate this project to him today, where it's an inspiration, where we all studied that Delhi Heart when we were in our school and we were growing, to design what we are doing right now. I hope we can match up to that, that level of dedication of what he had shown us with Delhi Heart INA. So having gone from there, what we wanted to do was create this project, which is not just a construction exercise, not just a collection of 250 shops that sell craft equipment or food courts, but does more than that. Because the building of the future cannot be just a functional design. We wanted to create a small project which is in this 5 acres, which changes the microclimate, which helps the environment and reduces the carbon footprint. As it happens with most of such large constructions, the footprint is huge. So we decided not to do any construction on site, except for a multi-level car park. The entire building or the entire structure would be assembly of upcycled shipping containers. We're using about 250 shipping containers. We've introduced these 30-meter high structures which harness sea winds at 25 to 30-meter height to bring those cool winds down to the ground level and change the microclimate of that area, the high humid climate of Goa at that ground level. So maybe the inspiration comes from those large wind towers of Sindh traditionally, which harness the wind and cool down the houses. We wanted to use that same methodology, but in this case, dehumidify the winds at the source itself where they enter, and then get the dehumidified cool winds down to the ground. We're also creating a large pond to collect rainwater of about 12 million liters of water. Plus, we are experimenting with biolume algae, which would convert the 4 metric tons of carbon dioxide generated from the car park of 250 cars every day into light and oxygen. So if you studied about biolume algae, it basically feeds on carbon dioxide and it gives out light in the night. And it basically gives you that feel of a living being that cleans the air. Nature has a lot of these fantastic things and we wanted to use that. That's the project. In order to understand wind, we did a detailed CFD analysis. It took us about 6 months to do that, where we got the real-time data from the meteorological department, a wind movement at every 3 hours over 1 year, and we simulated that to see how the wind could be brought down, whether it would work or not work with the structures, and how the structure could be sort of changed or revised or formulated, keeping in mind getting these winds. What we were aiming at was a feels-like temperature. A feels-like temperature is a combination of a dry bulb temperature that you measure on a thermometer, relative humidity, and wind speed. In simple terms, if it's hot, less humid, and there is wind, you will feel less heat compared to a high humid area. So we wanted to create a better feels-like temperature on the site. We considered in simulation the hottest day of the year in Goa, 7th of May, temperatures ranging from 31 to 35 degrees with almost 100% humidity. Wind speeds at 2.63 meter per second was used for the CFD analysis, and the major wind direction being northwest. Multiple data analysis, right from site, raw site data, structures, weather data was put into various softwares, including Grasshopper, simulated, combined together, visualized, and the visual result was put together, which I'm going to show you today. What we were able to analyze was that we were able to get the comfortable feels-like temperature from 23% to almost 44%, double the amount of what that would be achieved without the use of any air conditioning or any mechanical methods on ground. So like large open coolers, which would just run with sea winds. At half a meter, wind speed at 1.7 meter from ground level, the blue arrows that you see are high wind speeds. So we have generated from that 2.5 meter per second to almost 4 meter per second, increase the wind speed. And with the help of that central water body or the pond, the wind cools down even further because it's already dehumidified at the source. It would cool down further, get rehumidified again, and work exactly like a large desert cooler on a site like this. At the first floor level, the wind speeds have increased drastically, and by the time you reach the second floor, the wind speeds have already touched about 5 meters per second. A visual simulation, just to make you understand the principle behind it, is basically funneling that large wind from the top down to the ground and naturally ventilating the site. An adaptive reuse competition we entered last year in association with DRMA, Batul Raj Mehta and Associates. Batul, again being my batchmate from SET, was involved in the museum planning of Bihar Museum with Maki Associates. And we associated with them to formulate the program for this project. There's a competition that we were entering in Kashmir. This is an adaptive reuse of 120-year-old silk factory complex into an arts and crafts center. What was important was about this project, this is a site photograph. Who are our stakeholders? What is it that we want to build? How do we want to go about it? Three important questions. A conservation approach and methodology of studying each and every building, making detailed documentation through drone shots, through various things in between. The Section 370 came in and we could not go to Kashmir, but we had enough drone shots for us to generate detailed drawings and the entire model for us to simulate and work together. Our vision for the program was to celebrate Kashmir, revitalize the skilled craftsmen and the industry, and make the project highly viable by making it self-sustainable. Three stakeholders: local community, creative community, and the cultural tourists who would visit this Resham Khana. A cultural tourist platform, a community platform, and a creative platform with a functional diagram was developed by BRMA, which was given to us for us to work further on this project. It was a collaboration where we can continuously discuss and came up with newer functions that would work for a project of this kind. And we realized that in a disturbed area like Kashmir, which has always been for all these years, it was important for us to introduce something which is as neutral as science and mathematics, to inspire the kids out there, to inspire the new generations, to create a center which would take away from whatever is going on locally and politically into a new dimension of learning science being a neutral ground, to introduce functions like, or high energy, high activity functions like Parker Spaces, Skateboard Park, which have proved in a lot of disturbed areas in the Middle East and other areas where, to reduce stress levels and to use that pent-up energy into something more creative and useful. Add co-working spaces for the youth and the youngsters. At the same time, develop an entire integrated network of the craft industry. Also introduce a black box theater, an open theater, which would help in expressing or in an open expression in terms of its poetics of whatever's been there, the history and whatever's going on in Kashmir. A cultural tourist platform and a silk experience, because it's an existing silk factory and it's functional at 20% capacity right now, to create a live experience of silk where people could come from outside and visualize and see how silk is produced. Drew an entire micro level network of how each and every craft in Kashmir works and how they kind of integrate with each other and help each other out. Common tools, common waste produced, used by the other person, and what are the common factors that are used by each and every individual craft to work as an integrated network. This supplemented with a macro level industry spread all over Srinagar of how each and every craft usually works. We mapped the existing trees as usual again, mulberry trees, chinar and walnut on site. Studied the water flow. This is a highly flood flow prone area. Design intervention, we realized which buildings have to be restored, altered, some buildings that need to be rebuilt, and the newer construction which had come up as an ugly intervention to be demolished. A zoning concept emerged from there where we realized that there's a third space which is an undefined space that needs to be generated or created in the form of urban plazas within this. We simulated people. We created a lot of codes and simulations where we could basically look at densities versus occasions and events on particular days and simulate the most probable pathways taken by people. This helped us allocating functions to those existing buildings. So the most walked paths or the most walked areas or the shortest route taken through these multiple simulations helped us distribute the program in a more justified manner. We simulated various scenarios right from regular days to festival days to weekends and see what kind of public or people would go and travel to these places. There's an existing mosque out there built locally. We wanted to create a sacred plaza, remove the boundaries so that each of these plazas become another center for this craft center to grow further in a network which is in the surrounding areas. So right from a sacred plaza to an entrance plaza, a large public plaza, and a community plaza, including a residential court for the resident artist community, was conceived within this project. A design approach of zoning of interaction between the urban and the community the shade versus paved. We also proposed to use bricks from a lot of damaged, destroyed houses of Kashmir as memories within this project. So we didn't want to use any new bricks, but use all the assembled, upcycled bricks, which carry a lot of memories, to have this whole project as people's project. A detailed water network, which was not just water channels to carry water, but taking inspiration from the old systems of British, of how these large water channel systems, or something that has happened even before British and Mandu, could be used for as recreation spaces when there is no water. We changed the roof forms and we used the old sheeting, the GI sheeting, which has been, which is not really traditionally old. It has been replaced and put over the recent years, and use that GI sheeting into weaving these bridges that I'm going to show you. The overall plazas, views, scales. These bridges that you see, which connect like fingers between the various sections of the building, again inspired from the spindle needle relationship of a cocoon and the silk industry. The Sacred Plaza, where the mosque we decided to rebuild with the community and turn it into a large plaza for including a Baitak for Sufi functions. There's a lot of Sufism also in Kashmir, which we wanted to kind of increase and give and promote. We open out view. The extended roofs were an expression from the existing trusses, the wooden trusses of the building, as inverted trusses, the same angle, as a mirror image to create that interface between the outside and the inside. The urbanscape installation we did, what we studied in terms of creation of skin, we wanted to utilize it out here using the GI sheets that come down from the existing roofs of all those buildings, cut them and weave them like a silk cocoon, and create this entire bridges that run like fingers through these buildings as interconnections. So I'm almost done with the projects. Some of the studies that we're doing, we are also writing codes to do an automated parametric modeling, where for this project in Goa again, rather than, so what happens in government projects is that program changes, footprint changes, and you have to change all your drawings all over again. A building in this kind, which is conceived as a steel construction of various parts and components, we wrote a program where with the change of the footprint itself, the entire system could readapt itself by the click of few buttons. So we don't have to basically do working drawings all over again, change things, but just with the change of the program or the change in the line with few parameters, the entire system could be automated, which could go using the BIM software into the construction itself. So whether it's changing of the roof angle, changing of the extent, changing of the spans, changing of the footprint, everything is possible within this. And that would not only change the overall form, but redivide, recalculate, recalibrate all the individual members, including all connectors, by itself within a matter of minutes. Reconnected with the BIM software would help us change drawings in a matter of seconds or not even an hour, which could usually take days for any architectural office to do. We're continuously writing codes like this, codes that help us understand bylaws, help us automate certain buildings, building systems, skins, facades, services, all those kinds of things. An installation we did last year using sensors, using proximity sensors and using touch sensors, which could actually take in and change. So okay, the idea here was creating a room of illusions using multiple mirrors. Mirrors which were one-way mirrors and two-way mirrors. But two-way mirrors would get simulated with a light switched on or the program changing by how a person moves within this room. The paths generated with randomly spread or a planned spread of sensors under the floor tiles. So depending on whatever path you took, it creates a certain algorithm. And based on that algorithm, it changes the simulated scene of that viewer, what that person sees within this room. So creating multiple illusions for various users, each user has a different experience or a series of experiences, a series of programs that could be generated from a single space. With the use of reflections, illusions, sensors, we created this entire gamification of a space. Small video of what it is. Staircases, room of mirrors, objects, infinity staircases, a lot of these anomalies, and the sensor tiles. Was shot by photographer using a drone. Difficult photography because we couldn't do it by ourselves. The sensors would get activated, so the drone had to be brought in to shoot the entire space. The entire photography done without anybody entering the room. The programming, conductivity sensors, hardware to software was done within the office by Anuj, my partner, who's an expert with this. It took 30 days to program it, about 10 days on site. And that was the result. That's it. Thank you. Hello. Yeah. I'm open for questions now. I hope I'm in time. Yeah, 1 hour.
Yeah,
Manish, wasn't that too long?
No, that was not. But it was. I'm very happy that I actually not just coordinated but also attended the lecture, and I'm really happy and proud of what you're doing. Quite an eclectic body of work. A very since I've done my I've studied and I've done my master's abroad. And I'm in touch with a lot of friends who are working outside. So your practice is a very global practice compared to the kind of practices that I've encountered here. So again, brilliant work, Manish.
Thank you. Thank you. Thank you so
at
much.
At one point of time, it gave me goosebumps. कि यार कोई तो यहाँ पे ऐसा काम कर रहा है.
That's so kind of you. So kind.
No, I'm because when I was doing my masters, I'm not sure if you know him, Rudolf L. Khoury. He's he's written a book on Internet of Things.
Yeah.
Rector Dean of Miami School of Architecture, and I took a course with him where I was working with Arduino sensors, actuators, and then we were working on projects where we would develop sort of a mix of virtual and real space, interaction surfaces and all those things. But you have executed such projects and I mean converted these things into live actual projects here in India. Which is I was not aware about. This is the kind of work that you are doing. And very innovative again in terms of both materials and the technology that you have used. I have a question that is there a parallel thought process when you're conceptualizing your projects? Do you also at that point of time think about the material and the assembly that would go forward with these concepts later on?
Yep, I've tried to think about that a lot of times, and every time I have thought about material and construction as a first thought, I have come up with terrible results. So I've over the years understood one fact, and that is to think like a child. That you think for the first few days completely with the you know those problems are going to come. You know that it has to be built. You know there are going to be issues of economies, people, function, construction. All of those things are going to happen. But for these first few days, I keep it absolutely unadulterated with all of that, and that also goes with my team. We have this mandate that when we were doing this Goa Bazaar, for first 3-4 days we played with Jenga in the office. I'm not kidding. We brought in Jenga, a lot of them, and all of us, about 4-5 of us, just playing around, start playing with that whole wooden blocks, that experience of dealing with modularity. Just play. We could come out with out of the space of whether it will be built, whether it will not be built, because we know that over a period of time, with our consultants, with the series of engineers that we work with, they will make it possible. And we have never believed that anything is impossible. Anything can be built. But if we start thinking about how it has to be built in the beginning, we would not be able to think about it. So we think like a child all the time. It's like a craft exercise. Once we've gone past that, then we start putting in all the restrictions onto us. And so many restrictions that you can't even imagine, that even the client doesn't put restrictions onto us. We put budget restrictions. We tell our clients that if you have a budget, you tell us budget which is 20% lesser. I go back to my team and tell them a budget which is even 20% lesser. So that way we start with the project with a very, very tight budget so that we have a leeway to play with. But we still need to maintain that same idea and same concept that we thought about it as our craft exercise. And that is a mandate. So we are able to kind of weave in these things together. It takes a lot of struggle, a lot of work, a lot of hours to get that balance and harmony. But yes, somewhere we fail, sometimes we succeed. And what you see today is all the successes. I'm not showing the failures.
I'll continue with the questions that people have asked. Could you elaborate on conceptualizing the dominant forms in your projects? This is a question from Shreya Kaul. She's from Delhi. Could you elaborate on?
I'm sorry, I didn't kind of get the question. What does it mean in simple terms?
Could you elaborate on conceptualizing the dominant forms in your projects?
Like, why do I use dominant forms? Is that the question?
No. Conceptualizing the dominant forms in your project.
Yeah, so, okay. So for me, the form is a generation of thought process. It's not an isolated entity. It's not how architects, so there is I've had my career start in the event industry. After 3 years I spent in the event industry. I did not practice as an architect. I didn't go for my master's. I didn't practice architecture. I just left architecture abruptly after SEPT and went into events. And that helped me understand something beyond the physical realm or the physical built form. And that is the energy. Events usually have this raw energy within them. And there is this kind of underplay, which affects the human psyche. If you event a rock concert, the high decibel levels, the energy levels, there's a different feel to this whole thing. What I wanted to imbibe when I started architecture was to imbibe this energy into all these buildings that we do, that they're not static. And somewhere or the other, the function or what the requirement of that building is, for example, the Moulin Rouge dance school, the windmill versus the energy of the dancers that gets translated into the form itself. And the form translates into the spaces. So the kind of spaces that get formed are resultant of this churning of the windmill. What if the windmill was churning for multiple years and it resulted in distortion of those spaces around it? Or the National Institute of Water Sports, where the waves have kind of distorted the entire form and created it into a large wave itself. So what was important was to understand that energy within the building and imbibe it and keep it constant. So that's where the forms come
from. Talking about your Goa project, at what stage, there's another question, at what stage does MOFA involve building simulations, and how do the feedback received from the results help evolution of design for both Delhi project and Goa Art project?
all the time, all the time. Simulations are always an integral part of our design. We have discarded the entire form if it does not result in a result that we were wanting. So we have, when you do an innovation or an idea, you have a sort of a concept in mind. You vet it through simulation. Sometimes it comes very close. The intuitive idea comes very close to the simulation. Sometimes it's far away. When it's far away, we go back to the drawing board and we change, reiterate the entire arrangement. Though Guwahati itself was reiterated 5 or 6 times because we were not getting the right results from the simulation. So we were not like saying that we have defined a form now and we'll force the wind. You cannot force nature. Nature is what it is. Nature will remain and work in its manner. You have to work within the frequencies of the nature. So I cannot change the wind direction. I have to make the forms and the way they sit on site that take the maximum use from those wind energy that, or the wind that's coming from one side. So hence the simulation help us in coming at the final result, and we keep changing the form, the arrangement, the plan, the layout, everything till our simulations get satisfied. So intuition versus logic has to match seamlessly all the time.
I'll go to the next question. I'll just read out the question. Incidentally, is the experience of materialization of the concept of space the experience of the space? This is second part of the question. Is the materialization of architectural concepts necessarily material?
No, it's never the material. For us, it's never been the material. That's why we have experimented with materials which have not even been the building materials. So we never start with the material. We never have an idea in our head that we'll be using, let's say, a Coda stone flooring or an exposed concrete or wood or this or that. We have always been very, very open to using newer materials and to create new research. In fact, for one of our projects, again in Goa, for Goa itself, rather for NRWS, we are working with a WPC industry near Haridwar. So there are a lot of industries out there which produce wood plastic composite, where we are producing a new board which uses all the recycled Tetra packs in a new manner and turn it into a high strength board. So we keep using these ideas of generating new materials as and when the need of the project comes. There's never a material in our head. So if you saw the animation of NRWS, it did not have materials in the beginning. It was like this. Materials came in later. That's demand of the project. That's economies. And usually materials are always local. Again, going back to it, as local as possible, because most of our projects do not have high budgets. Being government projects, the budgets are low. We have to use local materials. So we have to combine these local materials with industrial materials together. That's what it is.
Is there also any place for virtual reality or virtual simulation in your practice? If yes, then can you throw some light on that?
VR and AR are visualizing tools more than anything else. And we've tried using VR and AR, both augmented reality and virtual reality. And that, especially in today's time, becomes extremely important after this post-COVID scenario where a lot of people would be scared to travel. We have projects all over India and we've been monitoring our projects now virtually. VR is going to be an extremely helpful tool for a lot of new clients to visualize spaces to its scale. A lot of times the 3D model does not give you an actual scale of the building. So VR can help you, give you that actual scale. You can walk through it, you can feel it. We've not used it. We have been working for all these years with actual physical models, a lot of physical models, a lot of virtual models. Never use VR for anything but for presentations a couple of times.
You've been using a lot of tools to manipulate forms, to sort of, you've been using Grasshopper, you've been using other scripting platforms to sort of manipulate form. Do you think in turn these forms have the ability to manipulate the user or the built environment? This is like one of the questions that I'm trying to elaborate.
It's to say whether there's an interesting essay by Umberto Eco whether the media affects the audience or whether the audience affect the media.
Yeah, something like that.
I think it's both. It's both ways. The forms affect your psyche, and your psyche affects the form. For us, coding and simulation has never been the means to generate a form. As I always said in the beginning, we play like a child, do our craft exercises, we come up with intuitive forms. We do not use computers and simulation to start the process. It's always a process that is used to vet the design. We use simulations to see whether the form works structurally, or whether the spaces works structurally, weather-wise, all sorts of things that I've talked about. It's more of a vetting tool rather than a designing tool for us. The designing still remains extremely intuitive. We still use clay models, we still use hand, we still use a lot of sketching in order to come up with an idea, in order to use that idea.
I think this is another question by a student. What softwares do you use?
Manu, you already talked about it. You
Some
already
easy-
answered those softwares.
Yeah.
And I keep getting this question. This is the most common question I get in most of the talks.
Okay.
There are multiple softwares for the students. Don't get stuck to one software. There are hundreds of softwares and apps available in the industry today. Use the software that you find it easy. A software does not define how you design. You choose the software as how you want to design. It's very important.
This is another question, and I'm just picking up parts on the parts. And it's a very long question, but what is the dependence on the building in the industry and the technology available outside uh, uh, for the projects that you conceptualize and you sort of take forward? Dependent on the technology, the construction technology and the building technology that is available to us. So what is your dependence? How do you what is your dependence on the technology? Building material and the technology.
We are dependent on technology, but more than technology, see, again, our projects are not high budget projects. If we could, we would use robotic arms. We would use all sorts of mechanized methods to do precise construction and not go through this painful method of what we have gone through. Goa, building that project has been a painful experience by using the low skill or the low cost kind of technology available to us. Had we got those kind of budgets, so just to give you a perspective, Louvre Abu Dhabi, we had entered with not Louvre Abu Dhabi, but Louvre, the Museum of Qatar, and National Institute of Water Sports 3 years ago for awards in Dubai, Cityscape Awards, and we were the final two competing against each other for the award. During the jury, it was discovered that our project was a similar technique of construction, but it was done at 1/8 the cost of that project.
Okay.
And that's not a joke. When you have limited budgets in this country and you still want to do parametric or this kind of architecture, you have to come out with an out-of-the-box thinking. You have to come up with techniques which are not easily available to you, which are not available like, okay, robotic arm would be easily available in the West. And we've seen that. Everybody has that. A lot of contractors have it. Or, the CNC routing, CNC cutting, or even 3D printing is become very common. But ask anybody out here about 3D printing or robotic arm. We've got maximum 7 or 8 robotic arms in this country.
Yes.
We have very few CNC machines which are cutting and bending machines. Nasik has only 2 CNC cutting and bending machines. Noida has 3. And look at the construction industry and the requirements out here. So the technology available to us is not at par with what's outside. We have to make do with what is available to us. So we have to optimize as much as possible. If I needn't use CNC, if I don't need it, I won't use it. I will simplify it. So I will design what I want to design, but at the same time, simplify the technology of construction because the resource is not available to me. It's as simple as that. I hope I've answered it. I went into too many tangents.
I think that there's no one answer to this.
There's no one answer to this. Yeah. You come up, you evolve as you go along. Something that we felt was impossible 4 years ago is possible now. Or something that can be done with a machine can be equally done with a hand. But it's just the way of thinking. It's just the way of putting resources together.
There are also your batchmates attending your lecture right now.
Really?
Yeah.
Who's that?
I think Parikshit is here, Rahul is here.
Oh, hi, Parikshit, Rahul, hi.
Probably they can wave a hand at you or something like that. Probably Bhavisha is also here.
Oh, lovely.
Okay. So, Manish, thanks a lot, and we'll conclude the lecture here. I think both they're waving hand at you. I think
Yeah,
this
I
is
can. Hi, guys. I'm so thankful.
Parikshit and
Finally,
Rahul.
we meet here of all the places. Thank you, Bhanu, for getting us together.
You're welcome. You're welcome. So I asked Rahul if you want a reunion after the lecture, we would sort of walk off the Zoom platform, and then all of you can sort of sit here and chat for a while.
Yeah, that would be great. That would be lovely if they're open to that, if they have the time.
So, Manish, once again, I thank you for sort of taking out time for us and giving us this opportunity to have you on this platform. The initiative that Mohit has started to sort of put together a discourse on the architectural and design education in the country. Once again, thank you.
Thank you, Bhanu. Thank you. I feel honored. Thank you. Thank you so much for calling me.
You're welcome. Yeah, and thank you everybody else.